Hi, we're going to figure out the acceleration due to gravity using this device right here. It's called a free fall device. And what we're going to do is we're going to analyze the distance time graph and the velocity time graph to figure out the acceleration of gravity on the Earth. We're going to use a device known as a spark timer. Now the spark timer, it takes the voltage from the wall, steps it up, and sends out a spark every 60th of a second. So when it does that spark, it actually will burn a hole through a piece of paper, and we can measure the distance from the first burn mark to all the others to figure out the acceleration due to gravity. Here's where you can see the spark timer work and hear the sound. Listen to the sound of the spark again, assisted with a little James Brown as well. Here we go. Listen for the spark. You can hear it go off and on. So what's going to happen is we're going to drop a piece of thermal tape between those two electrodes, and it's going to burn a hole in each one, and we're going to measure from the very first burn mark to all the others. So from 0 to 1, 0 to 2, 0 to 3, etc. And we put this little mass at the end so that the paper will fall straight down and not kind of flutter down because of air resistance. So there's the two electrodes, and there's the tape, and it will burn a hole in that tape every time it sparks, every 60th of a second. So here's me getting ready to drop a tape, and I have an assistant push down on the spark timer and hold it until the tape falls all the way through. As soon as I hear the spark, I release it. Here we go. And that's all the data that we need. Now we're going to analyze that data, create a distance time graph, use a slope technique to create a velocity time graph, and figure out the acceleration due to gravity on the Earth. Okay, let's take a close-up look at that tape. See, that spark timer will burn a hole in it every 60th of a second. And as you see, that first circle, that's 0. And then all those little dots were burned in 1/60th of a second later. And if you notice, the distance between each dot gets bigger. We're going to measure from the first dot to all the others to figure out the distance time graph. Then after we get the distance time graph, we're going to use an estimation technique where we're going to take the point before and the point after each data point to figure out the slope of the distance time graph. That's going to be the velocity. Then we're going to draw the velocity time graph. And when we do that, the slope of it will give us the acceleration due to gravity. And hopefully, we'll get 9.8 meters per second squared or 980 centimeters per second squared. Thank you. Tune in again later.